So let's talk about something that's on a lot of people's minds. How do we make talking to an AI, one that has access to basically everything, feel as natural and as easy as talking to another person? That's the quest we're on today.
We've all felt it, right? You ask your AI assistant a question, and then you get that pause. That awkward, unnatural gap that just completely breaks the flow of conversation and reminds you, oh yeah, I'm talking to a machine. This number right here, this is the goal. This is our North Star. See, research shows that for a conversation to feel natural, the back and forth has to happen in under 300 to 500 milliseconds. Anything more than that, and our brain immediately flags it as, well, just wrong. And the villain in this story, the thing that gets in the way of that natural flow is latency. It's all about the time it takes from the moment you stop talking to the moment the AI starts replying. Today, we're going to break down this whole challenge based on a really fantastic piece by Gokul.js that dives deep into the architecture of these real-time voice agents. Okay, so how do you even build one of these things? Well, at a really high level, you can think of a voice agent as being built on two core layers. And these two layers have to work together perfectly to make the magic happen. You've got the media infrastructure layer and the inference orchestration layer. And a simple way to think about it is this. The media layer is like the super fast highway for the sound itself, and the inference layer, well, that's the brain. That's where all the actual thinking goes on. Now, that media layer uses a really clever piece of tech called a selective forwarding unit, or an SFU. And its job is a huge win for speed, because it doesn't waste time decoding and re-encoding your voice. It just acts like a smart traffic controller, forwarding the audio packets directly. It's a massive boost for efficiency. And then you have the inference layer. This is where all the business logic lives. It's a real-time media consumer and producer. It's the part of the system that actually houses the AI's core intelligence. It listens, it understands, and it figures out what to say back. So what does that journey actually look like for your voice? It's kind of like a high-speed digital relay race. There are multiple handoffs along the way, and every single one has to be perfect and incredibly fast. Let's break down the actual steps in that race. So this is the classic four-step pipeline. First, the system has to realize you're even talking. Then it has to turn your speech into text. That text gets fed to the large language model to come up with a reply. And then finally, that text reply gets turned back into audio. Each component hands off its work to the next one in line. Let's start with voice activity detection, or VAD. This is so critical. It's basically the gatekeeper for the whole pipeline. It's listening and telling the system, hey, pay attention, someone's talking. And, just as important, okay, they're done now. If you get this wrong, you're either wasting tons of energy transcribing silence, or, way worse, you cut the person off. Next up, speech to text. And the key word here is streaming. See, modern STT systems don't just wait for you to finish your entire sentence. They're transcribing as you speak, and they send these partial or interim results down the line. And that allows the AI's brain to actually start thinking about a response before you've even finished your question. Pretty cool, right? And that brings us to the large language model. This is where the agent taps into its massive knowledge base of, well, everything to figure out what to say. But here's the other trick for speed. It doesn't create the whole response at once. It generates it token by token. This means the system can start speaking back to you almost as soon as the first few words of its own thought are ready. And finally, text-to-speech takes that text from the LLM and turns it back into a voice you can actually hear. Now, the single most important thing here is what engineers call time to first audio. Basically, how fast can it make that very first sound? That one little detail has a huge impact on how responsive the whole system feels. Okay, so we get the process now, right? We know the steps in the relay race. So let's put on our detective hats and go hunt for our villain, latency. Where exactly is it hiding in this pipeline and eating up all those precious milliseconds? Here's the really crucial point. Latency is cumulative. It all adds up. So even with a really well-optimized system, hitting that natural sub-300 millisecond conversational window is incredibly difficult. A tiny delay here, a tiny delay there, and suddenly you've got a noticeable conversation-killing pause. And you can see here, the delays are spread out all over the place. The speech-to-text system trying to figure out when you're done talking, that can add a couple hundred milliseconds right there. Then the LLM needs time to process and generate its first token, and the text-to-speech engine needs time to synthesize that first bit of audio. Altogether, they easily blow past our target. So, how do we fight back? How do we win this race? Well, engineers follow a set of golden rules. You stream everything you possibly can. You shave every millisecond off the time it takes to detect the end of speech. You avoid any unnecessary data conversions, and you physically put your servers as close to each other as possible. Every little bit counts. Now, all of this leads us to a fundamental fork in the road when you're designing these systems. It really forces a big choice. Do you want more precise, fine-grained control over every single piece of the puzzle? Or are you willing to give some of that up for pure, raw speed? On one path, you have the pipeline model that we've been talking about. It's modular, you can swap parts in and out, you can see what's happening at each step. The big downside, though, is that coordinating between all those separate pieces adds latency. On the other path, you have an all-in-one real-time model that handles everything. It can be a lot faster, but it's often a black box. You have less control, and you would get locked into a single provider. You know, there's no single right answer here. So if there's one thing you take away from all this, it should be this. Building a great conversational AI isn't just about having the smartest language model. It is a grueling engineering challenge. It's about mastering the flow of data against the relentless ticking of the clock. It's this constant balancing act between having control and the absolute relentless need for speed. And that kind of leaves us with one last thought. As we get better and better at closing this latency gap, as the technology to access everything becomes truly instant, what's next? If we completely solve the problem of speed, the next great barrier to making AI truly conversational, well, it might not be a technical problem at all. It might be something far more human.